Dear ladies and gentlemen, I have the honor to present to you the research on packaging technology, which is going on in the Department of Food Technology, Safety and Health. For this, I would like to show you following presentation that has been or that has the focus on balancing food waste and food packaging. This presentation is in a collaboration with these different colleagues that you see here on the slides. First, I would like to take a look to the roles of packaging or how packaging is perceived in society. And the first pictures I think that comes into mind of everybody is the massive amount of waste, and especially packaging, and in fact, especially a lot of plastic packaging in the environment. See a huge amounts of plastics in the oceans, in rivers, in the environment in general. But this is a very close link with the sustainability aspect of packaging. Now, besides, there are also some roles of packaging in society. And one of the roles that maybe not everybody knows very good is the fact that packaging provides us a way to bring food products from all over the world without in fact taking into account the seasons to local supermarkets. And for this, you need a very good distribution system, including a very good packaging. A third important aspect when we talk about food packaging is the way that it protects food. At this moment, currently, there is a lot of food products that get wasted. For example, for fruits and vegetables, that amounts up to more or about 50%. So about 50% of fruits and vegetables is lost somewhere during the or in the food chain. Does that mean that we have to pack everything? No, there is the truth is somewhere in between. But it is important to know that and to realize that packaging is a very nice technique to protect food products and to give them sufficient shelf life to guarantee that the product in the end reaches the consumers in a good quality, but also in a good safety. So when we take this all into account, we in fact, when we talk about food packaging, you should consider most of all the functionality, because again, food packaging gives the required shelf life to the food products, can also play a role in reducing food losses. But at the same time, we should aim for a convenient food packaging and also very important, as sustainable as possible. Each of these three pillars are investigated within the research group of packaging technology. This is in fact a group which is a close collaboration within, in fact, three groups. We have the group of packaging technology, we also have the group of food microbiology, and we have the group of food chemistry, all belonging to the Department of Food Technology, Safety and Health. This again shows that it's very important when we talk about food packaging technology that there should be a very clear link between food properties on the one hand, packaging properties on the other hand. More specifically, within the group packaging technology, the focus in the research is on the relation between the packaging requirements on the one hand and how it can attribute to guarantee enough shelf life on the other hand. Shelf lives both in terms of food quality and in terms of food safety. More specifically, the focus is on these three subtopics. First of all, bio-based and recycled plastics and how they can be used to pack food products. Active and intelligent packaging with focus on antimicrobial packaging and also sensors to monitor shelf life. And thirdly, how to optimize packaging configuration that it can guarantee the shelf life, but on the other hand, be as reusable or as recyclable as possible. Each of these three subtopics, I will give an example later in this presentation. Within our research, there is a strong collaboration with stakeholders all over the food chain. And I have here put some examples. For example, there is a close, of course, interaction with the European Research Programme and the European initiatives and strategies. To give you two examples, for example, the EU plastic strategy, which came up some years ago. One of the ambitions is that all plastic packaging should be recyclable or reusable in 2030. At the same time, there is a European Green Deal, which is, amongst others, stating that the Commission aims to cut food waste by half by proposing legally binding targets across the EU by 2023. There was also a strong collaboration with different consortia, for example, with the group of Pack for Food. Pack for Food is a consortium of more than 50 companies throughout the food packaging chain and of different research partners, all working on innovative packaging solutions with a strong focus on circular packaging. Besides, our group is also partner in the Capture initiative initiated by Ghent University. One of the pillars within Capture is the pipeline Plastics to Research, which brings together a consortium of interdisciplinary research groups on different recycling technologies, also for food packaging. As I have been mentioning before, I would like now to give you some examples of the subtopics within our research. So one of these subtopics was bio-based plastics. Bio-based plastics are or bioplastics in general are in fact different groups of plastics, which you can see here. The focus in our research is on, let's say, the new type of bioplastics, like polylactic acid, like starch, like, for example, polyhydroxyalkanoates, and also combinations of them, and how they can be applied for food packaging. For example, can we apply them for modified atmosphere packaging, which means that you need to have good gas barrier properties and in fact also good water barrier properties. So in fact, how can we use these type of plastics to use them as food packaging and to make sure that they can guarantee enough shelf life to the food product? Or for example, can we use these type of materials for in-pack pasteurization or in-pack sterilization? A second research topic is in fact in the framework of intelligent packaging and is about using and developing sensors to monitor shelf life. For that, you need, of course, to have a very good idea about which spoilage components are formed during the storage of food products. For example, there the expertise of the group of food microbiology and food chemistry is very important. Once you have characterized these spoilage components, you can develop together with other research partners a dedicated sensor that can capture the different spoilage components and translate that into a signal, which then can easily say if the product is still consumable or not. And such sensor is ideally to be integrated inside the packaging, in fact. A third example is the optimization of the packaging configuration. So here you see an example of another project called OptiBarrier. A project was coordinated by Pack for Food and was funded by the VLAIO, Flanders Innovation and Entrepreneurship. Here you see three different packaging configurations. And what is also typical about food packaging is that in, let's say, quite some cases, you have different layers of packaging materials linked to each other to give enough properties in terms of gas barrier or water barrier. Now, in general, the more complicated such a structure is, the more difficult it is to recycle. So the question is, can we also use less complex materials to also provide enough shelf life? And here you see an example of this ready-to-eat meal packed in different types, in 3 different types of packaging materials, where different parameters have been followed up. For example, the amount of oxygen that is entering in the package during storage at refrigerated conditions. And for example, linked to that, the growth of lactic acid bacteria, which are in fact determining the shelf life of the product. Then, for example, if you look to this graph, you see in fact no difference in lactic acid bacteria growth within the 3 different packaging materials. Now, as these are determining, in fact, the quality, the shelf life of the product, it could be decided in this particular case that in future such type of packaging could be used, which is a perfectly mono material and monolayer solution, which is also very good to recycle. So we go to a less complicated material without influencing the shelf life. This brings me to the end of my presentation. In conclusion, I would like to say that our groups are the ideal partners to make the balance between sustainable food packaging materials and their effects on shelf life and safety of packaged food products. And there's also food waste and how food waste can be reduced by using appropriate food packaging technology. This through our expertise, on the one hand, on packaging materials and packaging techniques, and on the other hand, on how packaging and modified atmosphere influences the quality and safety of packaged food products. I would like to thank you for your attention, and I'm happy to answer your questions.